Welcome to this explainer. Today, we're diving headfirst into a massive, honestly mind-bending question. Based on cutting-edge research and some pretty heavy philosophical forecasting, we're asking, what will our species actually look like 100 or even 1,000 years from now? Let's just jump right in.
So, when you picture humanity in the distant future, what pops into your head? Do you imagine this sprawling galaxy populated by beautiful, genetically perfect cyborgs, effortlessly hopping from planet to planet? It's a really fun thought, right? But if we set aside the Hollywood glamour for a second, I want to show you what the data and actual evolutionary biologists are predicting. And honestly, it is so much more complicated and, frankly, a lot more fascinating than the movies.
See, we so often picture this glossy sci-fi expectation of superhumans expanding into these massive galactic empires. But the scientific reality? It's far more gritty. We're looking at things like severe bone loss in space, and, if we look deep enough into the future, the potential loss of consciousness itself, in favor of this highly efficient, drab drudgery. So how do we get from where we are today to those gritty realities? Well, let's map it out. First up, evolution never truly stops. Let's look at the biology of today. Now, a lot of people just assume that modern medicine and abundant food somehow hit the pause button on human evolution. But that is a complete myth. Our bodies are actively responding to environmental pressures right now as we speak. Just look at recent history. Human populations have actually developed improved lactose tolerance so we can digest milk into adulthood. Certain groups have developed these remarkable, highly efficient adaptations to survive at extreme altitudes. And, thanks to better nutrition and sanitation, our average height has increased dramatically over just the last 2 centuries. The biological machine is constantly tweaking itself. What's really interesting is that we're now entering this era of technologically assisted evolution. We aren't just adapting to nature anymore, we're adapting to a world we completely built ourselves. Going forward, the strongest evolutionary advantages won't be things like sharper teeth or bigger muscles. They're going to be traits like resistance to novel diseases, or even how physically compatible we are with advanced technologies. And this acts as a perfect bridge to how our near-future environments are going to drastically change us.
Which brings us to the near future, how space literally breaks our biology.
NASA has a very real goal to put boots on Mars by 2040. But when you look at the source data on long-haul spaceflight, it becomes blindingly clear that our Earth-adapted bodies are going to struggle heavily out there in the cosmos. And the crucial number you need to know here is 20%. Without the constant, comforting pull of Earth's gravity, your muscles just don't get the stimulus they need to survive. Research shows that astronauts can lose up to 20% of their muscle mass in just 5 days of microgravity. 5 days! Our bodies just start rapidly breaking down without that gravitational resistance. And guys, that is literally just the tip of the iceberg. Up there, stem cells prematurely age, and cosmic radiation just tears through your DNA. You lose about 1% of your bone mass every single month, which dumps all this calcium into your blood and causes terrible kidney stones. There's even this wild condition called space-flight-associated neuroocular syndrome that literally flattens your eyeballs and messes with your vision. Plus, without gravity compressing your spine, you can grow up to 3 inches taller, which sounds cool until you realize it leads to severe back pain. Your heart literally shrinks because it doesn't have to pump blood upward against gravity, and your risk of blood clots spikes. Throw in decreased immunity and a completely altered gut microbiome, and yeah, this profoundly hostile environment pretty quickly dismantles that fun sci-fi fantasy of an easy galactic empire.
Okay, let's fast forward a bit. Moving into the post-human dystopia, the deep future. We're jumping from the physical hurdles of space to the philosophical hurdles of the future, guided by the incredible analysis of Oxford philosopher Nick Bostrom. He explores what happens when technology accelerates to the point where we can actually upload human minds into computers.
To really grasp what's at stake here, we need to learn a new term, eudaimonic agents. A eudaimonic agent is a being that is capable of conscious experience and engages in intrinsically valuable activities. We're talking about feeling joy, making art, experiencing humor, falling in love, and pondering philosophy. Essentially, it's the whole shebang, the very things that make human life meaningful to us right now.
So, picture this thought experiment. Imagine a future economy entirely made of uploaded minds.
Over here on the right, you have eudaimonic hobbyist humans. They retain complete, fully conscious human-like minds, and they still care deeply about joy, art, and relationships. But on the left, you have the mindless outsourcer. These agents are optimized purely for maximum economic efficiency. They use shared, standardized cognitive modules, like maybe they just rent a math module or a language module for a split second when they need it. And the kicker? They might completely lack consciousness, because feeling things actually waste processing power. So what happens in an evolutionary race? Well, the mindless entities replicate rapidly with extremely high evolutionary fitness because they are just so incredibly efficient. Meanwhile, the conscious hobbyist humans have very low fitness. To the system, they're wasting resources on fun. In a totally unrestricted environment, the mindless, non-conscious entities simply outcompete and replace the conscious beings.
Now, Bostrom points out that even if we don't end up literally uploading our minds into computers, we could still face this all work and no fun scenario. The future evolutionary fitness function might just ruthlessly select for agents who are willing to engage in nonstop, high-intensity drudgery, completely overlooking those who value leisure and play. In an extremely competitive future ecology, spending your energy dancing, joking, or painting might literally make you unfit for survival.
As Bostrom warns, and this quote really sticks with you, the world would end more gradually, not with a bang, but a whimper. We spend so much time worrying about artificial intelligence wiping us out in some massive, sudden cataclysm, but the real existential threat might actually be this slow, quiet process of optimizing away our own humanity and consciousness just to stay economically competitive. So let's talk about prevention and how we might start steering our own evolution. How do we actually stop this from happening? We don't just have to throw our hands up and accept this dystopian default course where brutal efficiency destroys everything we care about. Could we actively control our own evolution? If the natural path of technological evolution leads to a mindless wasteland, we have to grab the wheel and steer the ship ourselves. And that is going to require some incredibly strong, globally coordinated measures. To coordinate on a scale like that, Bostrom introduces the concept of a singleton. A singleton is a world order where, at the very highest level of organization, there is only one independent decision-making power. Now, hold on, this doesn't necessarily mean some tyrannical world government. It could be a superintelligent AI, a highly stable alliance of leading powers, or even just a strictly enforced shared moral code. The whole point is, to prevent a devastating evolutionary race to the bottom, humanity needs a unified mechanism that can enforce the rules of survival across the board. So, practically, how would this work? Well, once humanity forms this globally coordinated singleton, it steps in and intervenes in the economy and in evolution itself. It places a heavy tax on non-eudaimonic actions, like that extreme cognitive outsourcing we talked about. Then, it uses those taxes to subsidize eudaimonic traits. It is essentially paying agents to make art, to experience joy, and to maintain conscious, human-like minds. By doing this, it permanently modifies the evolutionary fitness function, artificially ensuring that being human and doing human things remains a highly competitive survival trait.
It is a massive, complex idea, I know. But it shows us that our destiny isn't entirely out of our hands if we choose to organize. So, I want to leave you with a final, lingering thought. As we move into this totally uncharted future, what human traits do you think are truly worth preserving? If we actually have to sit down and intentionally design the future of our species, what makes the cut? Think about that for a bit. Thank you so much for joining me on this explainer, and I hope this gave you a fascinating new lens to view our evolutionary destiny. Catch you next time.